Right, so first question here is integration by parts. Business students, you do integration by parts, don't you? Yeah. Do you use the letters F and G, or do you use U and V?
U and V.
What?
U and V.
Andy, be quiet. U and V, yeah? Okay. Please don't be shocked when I use F and G instead. Okay? So let's have a look at this one first. Can you all write that down? It's x squared EX, and it's 0 to 1.
Page 8.
Page 8, yeah. Can you see it? Write it down, yeah? Okay, so let's have a look at this. So we have, let me close that now. Integrate 0 to 1 x squared EX dx. Now, there's a rule at the start we have to use to check if it's in the right order. What's this rule called? Yeah. LIATE. So the X is which letter here? The A. And the E? E. So is the order correct? It is. Now what I like to do is then draw a box here. And I call this here is F, whereas business students you might call it U. And then this one here is G derivative or V derivative, if that's the letter you use. Then what you do is in this box is F, and this is F derivative, and this is G, and this is G derivative. And F is x squared, and G derivative is EX. And the reason I like doing this in the box is because it looks like going down means derivative, and then going up would be integration or antiderivative. So what's the derivative of x squared here? 2x. And what's the antiderivative of EX? EX. Good. Now we use our formula. The answer is FG minus integrate F derivative G dx. So that is x squared EX minus F derivative, which is 2x, times G, which is EX. Now, notice how we still have an integration. In fact, we have to use the rule again on the new problem. So we need another table now. So here's another table. And this table is only being used on this piece. Okay. So in this one here, F derivative, G derivative. Okay, so what's the F? 2x. And then the G derivative is EX. So therefore, what is the G? EX. And what is the F derivative? 2. Now just be careful, when we use our rule, it's only on this blue piece. X squared EX minus, big brackets, and now we use the rule. So the rule is FG, yes, minus integrate f derivative g dx. Now we're nearly finished it, because you can open this. X squared ex minus 2x ex plus 2 integrate ex.
We don't write one and zero in the integration.
At the very end I will, yeah. Now, this we know. What is the integration of ex? Ex. So we get 2ex. And then as you said, Amro, now we put the 0 and 1 in, but at the end, okay? So big brackets here for everything. The 0 and the 1 goes in. So first I put in the 1, and I'll get 1, so it's e minus 2e plus 2e minus, and then I put in the 0. So that's 0, 0, and 2.
Sorry.
Yep.
Why did you put the bracket for all of this? Why it's not for the
Because if you want to think about it like this, you can forget about the 0 and 1, okay? And if I just said integrate this, what would the answer be? Well, you wouldn't say, oh, it's only this. This whole line is the answer. So everything is inside of it. I know it looks confusing because the integration symbol is now only here, but it's still the whole thing that's getting the 0 and 1. So you can think about it like this, like big brackets. The 0 and 1 is for the contents inside, everything. Not just the integrating things. Okay. So this equals, shh. Now really I won't tolerate talking, okay? They cancel. So you're actually just left with e minus 2, which is 0.71828. 459045. Okay. No calculator. Ooh. Okay. Did they say in the question for the exact answer, or did they just say the answer? Let's have a look. They said exact. Okay, so if they said exact, that means only this is the answer. Exact means no decimal. No decimal. Yes?
If you use a calculator in step number 2.
Here, yeah. In other words, can you use the calculator here? The problem is the calculator will give you the answer as a decimal. Do you mean going from here to here, or from this one to this one? Yeah, again, you'll have to check, but I think the calculator would give you a decimal, and you don't want the decimal.
Because this one is easy to calculate e, but sometimes you have log and stuff like that.
Ah, no. I think in these examples when there's a log, well, it might be different, don't worry. It's always going to be something, if they want the exact answer, it's going to be something that you can calculate without needing a calculator. Like log 1 is 0, exactly, you know. Don't worry, if we get to it, we'll worry about it then. Okay, any questions on that one? No? Now, I know that this was in section B this year, but that could have been in section A easily. So it's not like you can completely avoid integration in the exam because you have a section A to do. And to me, that looks like a good section A question. Okay, how many marks did we get for this now? 5 marks? Well, not bad. Not bad. Okay. Now, this is the next part. So, this again is for both business science and engineering. We want to write this here as 3 fractions. What is this called? What's it called, this topic? Partial fractions. Yeah, and in this case it's proper or improper. Is proper partial fraction. So first write this down, and importantly write these three down as well. Okay, let's have a look at this one now. So, okay. Can I go on now? I'm moving on. So, can you read this, Amjad? Nobody can help you up there. No. Please read the two fractions back to me. So, the first one, the main one, what is it? It's 2 over 2 minus x brackets 1 plus x brackets squared, and that's equal to a over 2 minus, well actually, no, let me, we know how to do this one. So it's a over 2 minus x, and then it's b over 1 plus x, and then it's going to be c over 1 plus x. Oh sorry, I shouldn't have wrote the square there. And we know that we expect what up here? Cx plus d, but one of them is usually 0, and they tell you in the question it's c, is it? So there's no x here. But sometimes there can be an x here. We've seen that sometimes. Yeah, plus a d even, yeah. Business students, I know, usually this question in the exam is actually a little bit more difficult, because they sometimes don't tell you the A, B and the C. Sometimes. Most of the time they do give you these three here. Okay? But they don't always. So it'd be too much if I repeat everything. You should watch my video on Moodle about shouldn't they? Yes, they should. You should watch my video on Moodle about the partial fractions, okay? Because I explain in it how to know what you have to write if they don't tell you what to write. Okay? I think we spent, how long was it? 4 hours, 5 hours on it? Yeah, it felt like it. Alright, so let's have a look at this now. So what do we do next? What's our next step here? What do we do next?
Multiply by
Yeah, we multiply everything by these two brackets here. So just to save space, we have that and that squared, and then again, and then there's another one here, and then there's another one here. So what happens in the first fraction? Both cancel there. Yep. What happens in this fraction? The first one cancels it. What happens here? Yeah, but just the square, because it's squared. So we have one extra. And then the last one, what happens? That cancels that one there. So actually you'll be left with this. 2 equals a bracket 1 plus x squared plus b bracket 2 minus x 1 plus x plus c bracket 2 minus x. And just so you know, I just to save space didn't write what each of these are, but they're all the same thing, okay? It's just this denominator here being multiplied into all of them. Okay, so if you want to write it in fully in your notebook, what you write in each of these is that thing there, that denominator there. Oh, you can't really, this thing here. That's what each of these are. Okay, yeah. Alright, now, what we do next is we choose some value for x. So let x equal, what do we think would be good? 2 would be good, because that would go 2 plus 1, 3 squared, 9. So you get 2 equals 9a, so therefore a equals 2 over 9 is the first one. Do you do it a similar way in business? Do you do it the same way?
Yeah. Same.
Similar? Okay. Yeah? Okay. Now, of course it's possible. It's just in my worksheet I made all the questions not have fractions. But in the exam, yes, as you can see here. Now maybe I made a mistake, but it looks okay for the moment. Right, what will we choose next for x? No, before that I think. Minus 1. Because minus 1 would make this go. This would go as well. 2 minus minus 1, 3c. Yep. So you get 2 equals 3c. Therefore, c equals, try again, Eamon. 2 over 3. Oh, sorry, I thought you said it. What? Someone said 3 over 2. Wasn't you? Oh, it's Luke, was it? 2 over 3. Yeah, don't what? Alright, so we have 2 now. So there's one value left for x. So what should we use at the end now? 0, yeah. So we left x equals 0. So we get 2 equals a, 1 squared, plus b, which we don't know. And then this will be 2 times 1, so that's a 2. And that's square, so let me just get rid of that. And then plus c, and then 2 minus 0 is 2. Okay, so that's 2 equals 2 over 9 plus 2b plus 4 over 3. So that's 2 equals 14 over 9 plus 2b. So this would be 4 over 9. This is when I take it over, divided by 2. So 2 over 9. You're giving me the final answer, yeah? So b equals 2 over 9. Is it the same value as a? Ah, okay. Now, how many marks do we get for doing that? What was it? 5 marks? That's not bad. Okay. Now, question? Yeah? Oh, okay. One, two. You want to buy a what? A new one. You got enough paper for today? No problem, so. Okay, can I go move down now? Yeah, now is the tricky part. Now, the last part here is they want you to integrate this. which means it's the same as integrating these three here. Okay, so if I look at the question, they want you to integrate f. What is f? Well, f is this, isn't it? See, it says it right there. Or f can be written like this with the three fractions. This is the one we use because we just worked it out. So let's start that there. Okay, so yes.
If someone does something wrong,
Yeah, don't worry. It doesn't carry down for the marks.
so just like create something.
It's fine, yeah. Now, what was the A? 2 over 9 over, so what's the first one? X minus 2 minus X? Okay. Plus, what's the B? 2 over 9, wasn't it?
Yeah.
And then what was this denominator? 1 plus X. And then the last one, 2 over 3, 1 plus X squared. Now let me clean this up. I can write this as 2 over 9, 1 over 2 minus X dx, plus 2 over 9, 1 over 1 plus X dx, plus 2 over 3, 1 over 1 plus X squared dx. Okay, now this here is actually in the formula book. This one here is in the formula book, and this one here is in the formula book. I'll actually write down what's in the formula book. I'll open the formula book later maybe, but in the formula book you'll see a formula like this. 1 over AX, it was actually from semester 1 as well. That's equal to 1 over A log AX plus B plus a constant. That's in the formula book. It's in the formula book. So if I go here, if I use the formula book, what's the A here in this formula? No, it got cut out. It's minus 1 because the A was on the X. See, look at it. Look at it. It got cut out. Alright? So the A is minus 1 and the B is 2. And then here, A, what is it? 1. And the B is 1. And this one here is not in the formula book, so I'll show you what to do with that in a moment. So using the formula book here, this one becomes 2 over 9 times 1 over minus 1 log 2 minus X. Then this one here becomes plus 2 over 9 times 1 over 1, 1 over A, log 1 plus X. Plus, plus this one at the end. 2 over 3 integrate 1 plus X squared dx. We still have to do this one.
1 over 1.
Sorry. There. I know that looks ugly now. Oh, sorry, that's ugly. 2 over 3, 1 over 1 plus X squared. Okay, scrolling down. So this here becomes minus 2/9 log 2 minus X plus 2/9 log 2 minus X. Now, does anybody have any ideas on what I can do here? Go on. What about 1 plus X?
This is like the last question.
No, that's when it's 1 plus x squared. The square's on the x.
1 is 1.19 cancel.
No, I'm talking about here then. What can we do here? Oh, I feel desperation here.
X over the second.
Substitute.
No, that's what Muna was saying. It's not that one. Substitution. Substitution what? Let u equal what? 1 plus x. So let me go as a side problem here. Question? Don't be shy. Question? No? So this is a substitution. So we say let u equal, come on, 1 plus x. What does du dx equal? 1. So what does du equal? Dx. So going back here, this one now becomes 2 over 3, 1 over u squared times du, which can be rewritten as 2 over 3 u to the minus 2 du. Now what does that integrate to? What is it? U power minus 1 over minus 1, which is minus 2 over 3 times 1 over u. And what's u? 1 plus x. So that's the answer there for that piece.
Oh my god.
Yeah? What?
Zoom out.
Shh. Here, minus 2 over 3 times 1 over u. Yes? Are you sure? Yes. Minus 2 over 3 times 1 over 1 plus x. Oh.
Sorry, teacher. Can you zoom out?
I'm going to go back to the left now in a minute, yeah. Why, what do you need me to zoom out for? I'm going back to the
The U and the
what? At the start?
no, never mind.
No? Shh. Hey, stop talking. I'm going to go back to the main question now, okay? So you need this answer here. Yes? You got it written down? Yes? You wrote this down? So if I go back to the question now, I now have the answer for this piece at the end. What was it? Minus 2 over 3 times 1 over 1 plus x. Yes?
The second thing minus the either is
Oh, it should be 1 plus x, thank you. Okay. Yes, because otherwise we have a problem then. Now, what are the two limits here? What are the two limits? Andy, remember I told you you are only allowed in this classroom if you don't talk. Remember I said this?
Sorry.
Actually, you know what, Andy? You sit down the back, actually. Thank you. Now, keep going all the way to the back now. Keep going, a little bit more, keep going. Keep going. Yeah, there's okay. Yeah. No, between the chairs. You can sit on the floor.
Standing.
Oh yeah, standing's fine too. No, just sit down, just sit down. Alright, what are the two limits here? What were they? 0 and 1. Okay. So I put in 0 and 1. So Amjad, this is like what I was saying, you know, usually if they need the exact answer, the numbers will be easy to do. So I'll put in 1 first. So what's log 2 what's 2 minus 1 is 1. And what's log 1? 0. Now 1 plus 1 is 2. So this will be 2 over 9 log 2. And now here 1 plus 1 is 2. So this 2 cancels this 2, and what are you left with? Minus 1 over 3. And then we do minus, and then we put in 0. So this will be 2 minus 0, which is 2. So minus 2 over 9 log 2. And then this will be 1 plus 0, which is 1. And log 1, 0. And then this will be 1 over 1 plus 0, which is 1 over 1. So this will be just minus 2 over 3. Now they can open up. 2 over 9 log 2 minus 1 over 3 plus 2 over 9 log 2 plus 2 over 3. So that will be 1 over 3 plus 4 over 9 log 2, which maybe gets us nearly there. Yep, one thing left to do. So if you look at what you're trying to get to, they want a log 16 in the answer. They don't want a log 2. But there's something I can do with this 4, can bring it, yes, up as a power. So you got 1 over 3 plus 1 over 9 log 2 power 4. 16. No. Now write that down. This is really common in the exam. I think like this is in every paper really, this type. You wrote this down? Yeah? You wrote this down? Fix the cat. It's annoying me. Thanks.
Do you know the log method that we did for number 3 and
Yeah?
in the marking scheme? Can you
Yep. I talked about a quick way to do it, which I'll tell you now. So as Amjad pointed out, and I did say it before, there is a quick way to do this part on the side here. Let me show you the quick way to do it, okay? Watch carefully, this is not in the formula book, and it's a quick way to do it. Watch, listen, understand. So if you have something like, say, ax plus b power n dx, a quick way to integrate it is you increase the power by 1 and you multiply this number by this number and you put it down below. So for an example, okay, watch, 4x plus 1 power 9 dx. So that would be 4x plus 1 power 10 over 40. That number multiply that number. If you want to know the reason why, you can use the substitution method and you'll see that you get this result. So what you can do is, you know the answer will be this. What substitution would you need here? If you use u equals ax plus b, you do get this answer here. So it's like a trick. It's a shortcut. Now, how is that? What's wrong? No. How is that like the one that we had just a moment ago? Well, it's like this. If I had 1 over 4x plus 5 squared, that's the same as 4x plus 5 power minus 2. Isn't it? So then we increase the power. So what is the power now? Minus 1. And then we multiply these and divide and we get minus 4. Okay. So this is a useful shortcut here. This rule here.
And then you substitute x.
0 and 1. Go back. No, actually, I'll go to something else now. No, okay. Now, we'll do another integration one, but maybe not like this. We'll try and find a different one. So if I go to the next paper, no, too similar. No. You see, they're all really similar. They're all similar. I think you need to go backwards from the end. Or do you know one that's really difficult that you want me to do? There we go. What? Do you have... Hey, you all did this... Wait. You did some of these at home. So if there's one year you really want... I'd like to see, let me know now. Go check your notes.
This one is good.
This, yeah, well, this is good for sure, yes. 89? Yeah. Anything else?
The last thing.
What page? Well, I'm going to do this one here, you said. This one here looks very difficult. It is a bit difficult, yeah. Anything else?
Only going to be 3
No, it can be anything. Maybe. It depends, what? What? There's no question Q. What?
Let's do this first.
We'll do this first, yeah, I think it's a good idea. Okay, page 89. So write this question down, please. It's page 89 of the book. Yeah? Okay, did you write that down? Yes, what's wrong?
Next one.
You want to see the next one?
No, I'll show you the other one.
After this? Okay. All right. More paper. Can you read out the question? It's a fraction, I remember. What's on the top? And then on the bottom? DX. 5. Now this, listen up please. Listen, this is important. There's actually 2 ways to do this. You could use substitution, or you can use integration by parts. But what way did they tell you to do it in the question? By parts. So it's important that you use it by parts, because that is what they told you to use. Although I think substitution technique is easier here. but they ask for by parts. Now, what's the first problem here? If they ask you for by parts, what is the problem? The root is a little problem, yeah. What else is a problem? Yeah, what is the f and what is the g derivative? Because by parts you need to use when it's what type of problem? We could do this, yeah, this is what we need to do. When can you use by parts? When it's a multiplication. So as you suggested, we should bring the bottom up to the top. So we should write it instead like this. Now what power, Amro? Minus a half, good. So now it looks more like a multiplication. An f and a g derivative. What's that? I'll put in at the end, yeah. Okay? And you know why this is true, because you did this in semester 1 when you did the indices. Okay? Now, what do we do first with our integration by parts? What rule? This rule here. Now here's the second problem. What's the problem here with this rule? Both are algebra A. So I said this isn't good when this happens, but usually when this happens you put the simpler one first. So I think the order is okay here. Right, now we draw our table. Whoops. F derivative, G and G derivative. So F is 9x plus 2 and G derivative is 3x minus a 5 power a half. So what is F derivative? 9. Oh yes, my minus fell off. I think it's, no, it's not there. Now, it's good that I showed you the shortcut, because what do we do here is integration. So do you remember the trick? We make the power bigger, so what would the power be now? A half, you add 1, and then a half multiply 3, 1.5 or 3 over 2. But that looks very messy. So instead of 3 over 2, what do I write up here? 2 over 3. So I'll put the 2 up there straight away and clean this up. Should be 3 there. And that's a half up there. Okay? Now let's use our rule. So it's, where's my pen gone? F G, which is 2/3 3x minus 5 power a half minus F derivative, which is 9, times G, which is 2/3, and then again 3x minus 5 power a half dx. Let's clean this up a little bit. So this is 2/3 9x plus 2 3x minus 5 power a half. Now this will be 3 goes into that, so that'll be a 6 here, okay? This here becomes 6. Minus 6 3x minus 5 a half dx. Okay, what's nice is we have a quick way to do this here. So we, if you remember, increase the power by 1. So a half plus 1 would be 3 over 2. And then we do 3 over 2 multiply 3, which is 9 over 2, yeah. Which we should bring the 2 up here to make 12 over 9. But 12 over 9 is 4 over 3, isn't it? So we can clean that up to what did I say? 4 over 3, wasn't it? Yeah. 4 over 3. Okay, so as you said, Amjad, now we can put our limits in. What are our limits here for this? 3 and 2, yeah? 3 and 2. Alright, so calculators, let's see. Alright. 9 times 3, 27 plus 2, 29, so that's 29. And then, does 3 go into 29? It does not. Alright, so let's look at this one. 3 times 3 is 9, 9 minus 5 is 4, 4 to the power of a half is 2. 2 times 2 over 3 is 4 over 3, and then what did I say here? It was 29. So 4 over 3 times 29 is the first one. So 29 times 4 is 108, is it? So this becomes 16? Really? Oh, 116. No, that's not what you're saying. Are you sure? Good. And then here I put in 3. So 3 times 3 is 9. 9 minus 5 is 4. 2, 8. 8 times 4, 32 over 3. Okay. Which 68, 78, 86 over 3. Is that right? 86 over 3 here? 86 over 3, yes or no? 84. Of 84, thank you. I'm tired, man. 84 over 3. And now let's put in 2. Alright, 9 times 2 is 18, plus 2 is 20, which is 40 over 3. 6 minus 5 is 1, so it's 40 over 3 there. 3 times 2, 3 times 2 is 6 minus 5 is minus 4 over 3, so 36 over 3. Alright, 48? 48 over 3, is it? What? No, I don't have a calculator. Help a maths teacher out here, would you? What is it? Is it 48 over 3? 8, 9, and that 3 goes into that as 16. Yeah? Great. Now remember, I said you can check the answer on your calculator. So I think it'd be good if we can do that. Give us a calculator. Now, look. I'm sure you know this. In the exam, you can check the answer on the calculator using the integration button. Do you have this calculator? So you can type it in. It's fraction 9x plus 2 over square root 3x minus 5, and then it's from 2 to 3. Have you done this before? No? See, you can I'll type it in on the calculator chat. You can't on that one, sorry. But you can on this one. Do you know how to make the x? It's the alpha button. And it's there. Alright, I'll show you over here. It's interesting on the calculator using this one. And to make it act, use alpha and x there. Okay, so you can just type the numbers there. And be sure that grab 16. And it does. Oh yeah. This button here, you can type it in, to make it X, press alpha X. This yours, remember? This is useful because it means that the exam, you know if you got full marks for this question. Okay, how many marks for this question was it? How many marks for this question? 5. Okay, so let's look at the next part, more difficult. Here, if you need to finish writing the bottom down, there it is there. No, there's a B part still. Slow down, Eamon, slow down. Okay, can I go back to the question now? Okay. So, can you please write this one down? Next part. Okay, did you write that down? Yes? Okay, let's have a look at it now. Okay, so what is the main fraction, please? Yeah. Plus or minus? Plus 7x? Minus 7x, okay. Plus 17. Over? Yeah. X minus 1?
Yes.
Right. No, Eamon needs to speak clearer. X minus 1, bracket.
X squared plus 4.
Right, equals A.
2 in front of X minus 1. Bracket.
2 in front of here?
Yeah.
No, this will be.
No?
I don't know where I have been talking.
They don't know anything. Right, A over...
X minus 1.
Oh, but we know this one. And then it'd be... This here is a quadratic that has only... It has no... Doesn't look like it has any roots there. So anyways, what's the next one? It's x squared over plus 4, isn't it?
Yeah.
And we know here is bx plus c. And we could have the b and the c. And do they have the b and the c?
Bx and C is individual.
Oh, look at what they did there. Of course, you can put these two together as one fraction because it's the same denominator. Can you see that? So I will not separate it like this because in class we do it like that, don't we? But that's the same thing. Okay, so we'll leave it like that. Okay, so what do we do first as normal with these? We multiply everything by this denominator. So I won't write down, yes, Sanjay, denominator. So I won't write down these steps. We can see the answer will be 5x squared minus 7x plus 17 equals A. x squared plus 4 plus bx plus c x minus 1. Okay, what do we choose for x first? No? Not minus 1. 1. You let x equal 1 first. So this will be 5 minus 7, which is minus 2, plus 17, which is 15. Andy, are you okay down there?
Yes.
Equals 5a. So therefore, a equals 3. Now, what do we choose for x next? 0, you say? I think so. Let's choose 0 next. So, x equals 0. We get 0, 0, 17 equals 12, because that's 3 times 4. 0, so minus c then. So therefore, c equals minus 5. Minus 5. Yes, okay? Yeah. And finally, it actually doesn't matter what we use for the last value, so I think minus 1 will be fine. So this will be 5 plus 7 is 12, plus 17 is 29, equals 5 times 3, which is 15, yes, 5 times 3, 15, yeah. And then here, b we don't know, but c we know is minus 5. So plus b, minus 5, times minus 2. So that would be 29 equals 15 plus 2b plus 10. So that would be 25 for b is 2, will be the answer from that. Okay? Okay, so now the next part is they want you to integrate now. Okay, so they want you to integrate these two here. So tell me what the A, B, can you read these out to me, but with the A, B, and C inside of them now? So what's the first one?
3 over x.
Thank you. 3 over
X
minus 1 plus 2x. Wait, hang on. Okay, 2, yeah, that's the B, sorry. 2x over x squared plus 1. I need to write it a bit smaller anyways. 2x, okay. Plus 2, was it? 2x over x squared plus 4 dx. And then finally, minus. Is C minus 3 or was it 3? What was it?
minus 5.
Oh, minus 5. 5 over x squared plus 4 dx. Okay. The first one, how do we do the first one?
3 log x1.
Yeah, it's in the formula book, like the last example. So this will be 3 log x minus 1. The second one, how do we do the second one? Yeah. Go on. Equal. What method are you using? Yeah, you need to use the substitution here. So you let u equal x squared plus 4. Okay. And then this one here, yeah, you let u equal it'd be x over 2. Now wait, listen. Business students, not for you. Business students only do these two. This one here is the science and engineering, do this one, okay? Yes, because they're so lucky, aren't they? So, these two, everybody in this room needs to do these two, okay? Now, these two are just substitutions, okay? So you know how to do these. You say u equals this, and then you say du dx equals 2x. You remember, you know the process, right? So I'll just go straight to the answer for this one. It'll turn out to actually be log x squared plus 4 when you do it, okay?
How do you report the...
Oh well, masters, so it's the reason, you know. Is there? Is there?
Yeah.
Alright, I'll tell you my secret then. There is a trick I can do in the middle one as well. I don't like giving you too many tricks because you can't handle it, okay? But there is a trick here. And the trick is this. If you can spot that the derivative here matches the top, so like if this is an f and this is an f derivative, you know the answer will be log f. So for example, if you had here x squared plus 1 and here is 2x, because the derivative of this is exactly the top, I know as a shortcut the answer will work out to be log x squared plus 1. Yeah, now look, only use it if you can handle it, okay? Yes? So it's a trick, it's a shortcut again.
So it was wrong question. You said because of the master, so it was...
I have no problem lying to you. It's not a problem for me. What? Sure is. Don't worry, I'll give some extra money to charity. It'll be fine. It'll be okay. Okay. Now, the last one here, this is, like I said, is only for the science and engineering students, so I'll try and do it quickly on the side here, okay? So, what does du dx equal? That would be a half. So, du equals dx over 2. So what does dx equal? 2 du. So this becomes 5 over x squared. So that's 4u squared plus 4. And then this one here would be 2 du. So it ends up being 10 over 4. 1 over u squared plus 1. And we know that this one here, what's that? So tan inverse 5, tan inverse u, but what's u? X over 2. But I mean, we did a whole worksheet on this. I don't want to spend much time on that. You did it, and the business students don't do it, okay? So the answer will be 5 over 2 tan inverse x over 2. Hang on. If you have a question, you can ask me. It's okay. I won't be angry at you. I'm only angry at Andy. Okay, so if I go back here now, yes, I have the answer. Can you read it back to me? What was it? 5 over 2 tan inverse x over 2. Okay, now what are the two limits here? What are the limits here? 4 and 2. So let me put in 4 first. So it'll be 3 log 3 plus log 20 plus 5 over 2 tan inverse 2 minus, and let me put in 2, 3 log 1 plus log 8 plus 5 over 2 tan inverse 1. Now let's clean it up. What can I do with this 3? Bring it to the top, right? So that would be 3 cubed, which is 27. So you get log 27 plus log 20. Now, in radian mode, because remember it's radians here, what's tan inverse 2? If you check it, you'll see that it's a decimal. You see that? Check it. Tan inverse 2 is a decimal, isn't it? Isn't it?
Yeah.
So we'll leave it as tan inverse 2. We don't want decimals. What's log 1? 0. Minus log 8. Now, tan inverse 1 is not a decimal. If you check it on the calculator, it'll be pi over 4. So this will be minus 5 pi over 8. Because this is pi over 4. And there's a minus there. Okay? Now, when you add logs, what do you do to the numbers 27 and 20? When you add logs, multiply them. And then when you minus, so this is log 27 times 20 over 8. So see what the inside simplifies to. Plus 5 over 2 tan inverse 2 minus 5 over 8 pi. So let's see, that's a 10 and that's a 4, that's a 5 and that's a 2. So that'll be 270 divided by, okay, so it's not a whole number, it's going to be a fraction. So what do you get here? What is it? As a fraction? I think this is the final answer. We can check now. Yeah. How many marks? 6. All right.
But the answer had a minus 5 on account 5 over 6.
It did have a minus, or it didn't in the answer? All right, hold on. Let me just check. Well, actually, you know what? I remember one of these is actually the sign. One of these answers is wrong in the past exams. I think it might be a typo. But I mean, how can we check which is the right answer if I made a mistake? The calculator. So what I'd like you to do is go back to the. Oh, we don't have it here. I'd like you to type, listen, I would like 2 people, Eamon and Amjad. I want you to type this here on the left, alright? And Quantum and Company, I want you to type this in. We'll see if they match. If they don't match, it means they should have put a minus here. Question? No. Do you have your calculator that can do this? What?
In business exam, we won't get question like this.
No, you will get one like this, but I mean, it won't have this part in it. Okay? So, the only thing that's different for you is that your one, you will never get a piece like this. So, in your exam, the C here, in this example, will be 0. You don't get these problems in business, okay? So, this means you don't get the tan. You could get this question just with the C equals 0. Okay? Wait, slow down. Which is right, which is wrong here? It is a plus then. No, hang on. Did your number match their number? So that means I lost. Listen. Hang on, it's a simple question. Did the answer you get match their answer? So that means the plus is correct, yes? So that means I lost a minus somewhere. So help me find my minus. Where did I go? No, don't. You don't need to talk. Just look up here and find where the minus disappeared. I mean, this here looks like a plus. That minus and the plus makes minus. So then it makes me think that this is wrong. Oh, there we go. Found it. Here it is here. It should have been a minus there, which meant it should have been a minus there. Which meant it should have been a minus there, which meant that is now a plus, and a plus. Yeah. I was, look, here it was here. I changed my minus by accident to a plus here. Okay, that should have been a minus. So it just carries down. It carried all the way down until the end. So I'll change this now to the correct one, a plus. See, this is why it's useful on your calculator to check the answer. Because now if I was in the exam, and this happened to me in the exam, I know I made a mistake. That forces me to check. I found my mistake, I fixed it, and I got full marks. And this is what you need to do if you're aiming high. Okay? So here, if you need to write something down there you go. Now, one of you had a question you wanted to see. Which one was it? What? This is the... Okay. Anything else then? Double check. Well, the question will be different, so the numbers will be different, yes. So then make the question so that the C is 0 and you don't have the tan. Page 83. Okay. Yes. Which part? Or all of it? Alright, well I'll do the A part. So, you're chatting on your phone, aren't you? Don't look away. I'm looking at you, yeah? What were you doing on your phone? Hey, do you know if I should believe her or not? Is she trustworthy? I'll believe you this time. Should I believe you? I don't know. Now, business students, you will have something like Part A that is on your exam. Let me show you. For business students, you'll have Part A, okay? But Part B you won't have on your exam. And we don't have too much time left. So for just today, I'll just do the Part A, and we can look at this maybe some other time then. Maybe next week or maybe in class during the week, okay? But Part A you could have, okay? This is a topic on the exam. Do you know about the volume when you rotate it? Yeah. So I'll do Part A. also, I should say, business students, if you want to ask Joan for past papers, or do you have past papers already? You don't? So if you want to ask Joan for the past papers, because I told her I'll do past papers in the class, and she said that's a good idea. So you can get the past papers from her, and you can then tell me which ones you want me to do. Okay? So maybe you can email her, or wait, do you have her on Monday? Yeah, you can ask her on Monday then, okay? Right, so part A here. So I want you, it's like a special needs class, it really is. Just write down those 2 points, please, 0, 3 and 4, 1. You got that? 0, 3 and 4, 1, okay. So what happens here? What's the first point? 0, 3, which is here. And then the second point? 4, 1. And then they join a line between them, and then they rotate it. So they rotate it, they make a volume. First thing we have to do is we have to find the equation of this line. What's the equation of this line? Well, you did it in ICT this morning. Y equals mx plus c. Now, this is like semester 1. How do we find the m? Well, the m will be, we'll do 3 minus 1 over 0 minus 4, isn't it? So that's 2 over minus 4, so minus what the heck? Sorry. No, that's something went wrong here, alright, let's try that again. y2 minus y1 oh, this is the problem. Yeah, that would be a problem, alright. Alright. 0, 3. Aha! 4, 1, yes, okay. Alright, so that's going down. And we rotate it. Okay, so the m will be 1 minus 3 over 4 minus 0, which is minus 2 over 4, which is minus a half. So I get y equals minus a half x plus c. How do I find the c? I substitute in a point. Which point should I use? I should use this one. And it gives me, maybe somebody can tell me straight away, what would the c be? It'd be 3.
But how do you know if it's tangent or normal?
Oh, that, what do you mean?
Like, you need to change the m.
No, not for these, no. It's being rotated. It's nothing to do with tangent or normal. Yeah, just a straight line. Now, we use our formula for the volume. Who remembers that? Volume equals pi integrate. Now, what will be the limits? From where to where? From 0 to 4. Minus a half x plus 3 squared dx. And we can use our trick we learned today. So this will be minus a half x plus 3 cubed over minus 3 over 2. And what limits go in? 0 and 4. So let me clean that up a little bit. That would be pi minus 2 over 3, because the 2 goes up. And then we have here minus a half x plus 3 cubed. And then we put in the 4 and the 0. Okay, let's put in the 4 first. So 4 times minus a half is minus 2. 3 minus 2 is 1. 1 cubed is 1. So we'll have minus 2 pi over 3. Now I put in 0. 0 times a half? 0. 3 cubed? 27. 27 times minus 2 over 3 pi will be minus 54 pi over 3. Isn't it? No. Yes? Yes. This is 27 times this number here. I know I can simplify it. 27 times that. Okay. 52 over 3 pi is the answer. Now, let's check it. Abdul, can you just tell me what 52, can you tell me what that is as a decimal? And then, Eamon, look up. Can you type that integration in exactly as you see it on the screen there, okay? Alright, we see if they match. If they match, it means we got it right.
Must have to be works.
Yeah. It was 54. Okay, wait, please. Yes? Well, what's your question? It doesn't actually matter which way around, yeah. Somebody else done the integration part? Yes? Decimal? Oh, again, the exact. Well, that's nice. That's very nice. Good. So, how many marks were for that? How many marks was that one? 5 marks. Yeah? Now, wait. Whoa. Slow down there. Now, I can't, remember science engineering students, you can't do the vector questions yet for the weekend because we're not finished the chapter. But it would be a good idea to have a look over number 1, 2 and 3 again. Look at the ones you couldn't do the first time you did it and see if you can do them now. Okay? Physics students, I want all of those question ones, not question ones, you know, the mechanics part 1 done. I wrote them on Moodle, the numbers. And then the business students, I want you to tell me before Friday, before our next class, which topics you feel you really need to see. Yeah, I have no idea what's happening next Friday. Some stupid ETAP thing going on, so I don't know. So maybe it'll be a different day. I don't know. But before the class, could you email me or maybe just tell me what parts are really difficult for you in the exam, or do you know yet? Like which chapters are very difficult for you? Do you know which ones? Integration is a difficult one. Yeah. And what about the probability or like other chapters? You're not business. It's all the same? Okay. Well, just think about it. Andy, now sit back down. I didn't tell you to go yet. Just think about which ones. And for you as well, just think about which ones you want to see in the exam and you can let me know. Alright? Huh? Alright, see you next week. Yes. Oh, I will put this video, it was recorded, I'll put it on the science and engineering page. I'll call it revision lesson 1 or something at the bottom of the page.